Okay, good morning, everyone. Thank you for joining this session on getting started with Jakarta NoSQL and MongoDB. Greetings from Flemington, New Jersey. Let's get started. So who's Mike? So I have a degree from Rutgers University here in New Jersey. I've worked for ExxonMobil Research and Engineering for almost 32 years. That's the petrochemical research organization. And in my spare time, I do a lot for the Java community. I've been a Java Q news editor for InfoQ since 2016. I'm now the lead editor in the Java space. I've been running the Garden State Java user group for just over 20 years. And I've also been a member of the Jakarta EE ambassadors. And before that, it was the Java EE Guardians. So the objectives we have today, I'm going to talk about what Jakarta NoSQL is, what is Eclipse JNoSQL, to go over some NoSQL database types, talk about the two different Jakarta NoSQL layers, and of course, a demo is always the best for everybody. Okay, there we go. I had a window pop up in front of me. Sorry about that. And then talk about some resources at the end. All right, so first of all, what is Jakarta NoSQL? It is one of the specifications of about maybe 30 in the Jakarta EE space. Otavio Santana, who I believe is speaking at this conference this week, is the specification lead. And this basically streamlines, any, integration of Java applications with NoSQL databases. And there are plenty of them out there. And we'll talk about that a little bit. And there are a set of APIs for you to programmatically develop and work with NoSQL databases. So also, it is also considered one API and many databases. And you'll see that as we go through the rest of these slides and the example. And the Garden State Java user group has adopted this specification. In case you don't know, all of the Jakarta EE specifications can be adopted by Java user groups or individuals. And you can see that if you peruse the various specifications, and you'll see which Java groups or individuals have adopted it. So by this, I've contributed to the specification over the past number of months. Look forward to continuing to do so. All right, next is Eclipse JNoSQL. And this is the compatible implementation of the Jakarta NoSQL specification. One defined API for each NoSQL database type. And there's the use or consistent use of annotations so that you can map Java objects to your NoSQL database. And before I forget, if there are any questions, please chime in at any time. This gives me a natural break because I tend to speak a little too fast. So in any event, let's so we have the NoSQL database types. There's key value, column family, document, and graph. And MongoDB falls in the document NoSQL database type. And we'll touch on some of these before we get into the application. Okay, the key value database type or NoSQL database type, as you can see, is the simplest of all NoSQL databases. The client is allowed to, for example, get the value for a specific key, assign a value, delete a key, for example. And the value itself is basically, a binary large object or anything really, or whatever you can actually store in there. It's the responsibility of the application to know what is stored in that particular database. And because this is very simple, this has excellent performance. and can be easily scaled. And the use cases for key value NoSQL database is storing session data, maintaining schemaless user profiles, and storing user preferences. And example databases will include Redis. I think a lot of us know or familiar with that particular database, MemcacheDB, and React. And a lot of times I like to have a comparison of NoSQL to relational. And as I studied MongoDB, I was able to see that. So, I did a little research on some of these other types here and came up with these tables. So synonymous to a table in the relational world, in the key value world, that's known as a bucket. And as you can see, the key value pair is synonymous to a row. All right, the column family, I think this is one of the most of the complex of the four. And the data is stored in cells grouped in columns of data instead of rows. So basically, it's just the opposite. And columns themselves are grouped into column families. As you can see in the cartoon here, it's hard to see in this picture, but the left-hand side of that is a row key, and then the right is column. So you can see how there's a grouping. And the column families are grouped of similar data that can be usually accessed together. And the main advantage over the relational database world is fast search and data aggregation. And we've used one of these databases for content management systems, blogging platforms, and applications that require heavy write requests, such as log aggregators. You do want to avoid using this if you have a lot of complex queries. And the same thing in the document database. So MongoDB, trying to query, a MongoDB database, which I've had experience in doing, can be very very complex in terms of all the number of parentheses and the curly braces. And also here's the comparison to the relational database world. The table is basically a column family, and a row is a column, and the column itself is a key value pair. Document database, MongoDB, and this is similar to a key value. The value itself is structured, and it is in JSON format, as you may have recognized here, and it's actually a binary JSON format that MongoDB uses to store the data. Again, just if you have a lot of complex queries, you may want to try to avoid this particular database or database type. And the use cases are e-commerce applications, and you can also use this for content management systems. And a table is considered a collection in MongoDB or a document database. And a row is a document itself, as you saw on the cartoon a couple of slides ago. And it's a key value pair for a column. And last but not least is the graph database type. This is also kind of complex. And if you remember your graph theory from your computer science classes, you'll see there's nodes and edges, just like you studied back in those days. So this is the same kind of thing. You can see the relationships here, between the different nodes. And this is built on what's known as the entity attribute value model. And you can, in a spatial efficient manner, you can encode the entities. And this is a flexible way to describe how data relates to other data. And use cases are in fraud detection, graph-based search, social networks. And example databases are Neo4j, ArongoDB, and OrientDB. And just like I mentioned before in graph theory, a vertex and an edge is a table, and the vertex is a row, and you can see the rest right there. So I'd like to study this, actually. I think if I ever had a chance to do so, I think this would be very interesting to do so. Neo4j, I know, is a very popular database in itself. Okay, so you have the different layers, and there are the two of them, communication and mapping. And if you've seen early versions of this, especially blog posts that give you an example on how to implement Jakarta NoSQL or Eclipse JNoSQL. This was formerly known as Diana, and then the communication, and then the mapping layer was formerly known as Artemis. So just wanted to mention that in case you happen to see those. And you can see how all these layers fit together here. So you have the mapping and communication layers, and you can see that they relate to the 4 database types, the NoSQL database types. Okay. I don't know if I can access the chat here. Okay. All right, nothing there at the moment. Excellent. All right. So the communication layer itself is a set of APIs that obviously defines communications with any kind of NoSQL database. There's modules representing all 4 of them, and you'll see that in the example, and I can try to make a comparison to which one would be which. So it's a very organized set of classes and interfaces to use. And you can compare this to the JDBC APIs. And if you've worked in the relational database world. Oops. The mapping layer is a set of APIs that, similar to Hibernate ORM that map Java objects to NoSQL databases. And this layer incorporates the two other Jakarta EE specifications, namely context and dependency injection and the bean validation. This is annotation driven. You'll see that in the example, and you'll see some similarity to JPA with the annotation. So this actually was designed to make it more familiar and to more easily get started in the NoSQL world. All right, scalability versus complexity. Key value, of course, is the least complex, but the most scalable. And you can see the other 3, how they fall onto this graph right here. So, the graph is the most complex. So I misspoke before when I said column was, but yeah, so it's the least scalable, the graph NoSQL database type. All right, this is I believe this is a short list of the NoSQL databases that are supported. A lot of them I'm sure you're familiar with, MongoDB, of course, the Solar, Neo4j, you can see Hazelcast, of course, IM DG, although it's the Hazelcast platform now. The version 5 was just released, ArongoDB and Cassandra and Redis and all the others. So. All right, anybody ready for a live demo? That's a rhetorical question, I'm sure. All right, let's get started with that. So I have an application that I put together, and I figured this is a popular topic, and I'm also a craft beer enthusiast, so why not demonstrate a beer database? So I'm running MongoDB, and I have Compass here. So let's just go over the database itself quickly. So in this beers database, I have 2 collections, a beer one and a brewer, and we'll use these together. So having come from the relational database world, you can't help but try to normalize tables like you did with MySQL or with any other relational database. So I've done that here, and there is a way you can do an inner join, but that's not the topic of this presentation. But you'll see how we how I put this together. So in the beer collection, basically I store the ABV, the name, the brewer ID, that will obviously correspond to the brewer collection, and the beer type. And you can see I have 16 beers listed in this particular collection. Okay. All right, so there's a lot of good ones here. And then in the brewer collection, I have 23 of them, and we're going to add to that with our application today. We're going to programmatically add that using Jakarta NoSQL. And in the brewer collection, I have the name of the brewer, the city, and the state. Very simple, nothing too complex, and we can go from there. So we have a whole bunch. There's you're going to see some from New Jersey, Pennsylvania, New Orleans, since my wife and I go down there quite a bit, and some new ones that we've discovered over the last few months. So going to our application now, first thing we're going to do is we're going to have corresponding POJOs for both of those collections. Okay. All right. So you can see we're using the Jakarta NoSQL mapping, the column, entity, and ID annotations. And similar to JPA, we're going to have the entity app annotation, and we're going to have our class. And as you saw in the compass view of the database itself, we're going to store the ID, the name. So we have the ID annotation, the column annotation, the beer. Oh, there's a beer type. Let's open that. That's basically just an enumeration. All right, very simple. And one of the things you can do with the column annotation is to define the actual attribute within that within the database itself. So, for example, I'm using brewer ID. Brewer ID, right, is number one here, right? But, generally using normal, POJO type style, whatever, I like to use brewer ID in camel case like this instead of the underscore. So you can actually map, this variable to the column in the database itself. So that's something that's kind of useful that you can use. You don't have to do this. As you noticed, I didn't do it in the other ones, but in this case, since we had an underscore in the database, that's we resolved it that way. All right, basic default constructor, and then a primary constructor, as I like to call it. Okay, and then the getter methods. That's I think we all know how to do that. A toString method that we use, and then I have a builder class here to basically use the sort of the streams format to create a beer object. All right, and this basically is very similar, and you correspond the ID, the name, and the type. And I'm using brewer ID here in the method name itself. And then there's a build method that will actually create the new beer. Now you can say, Mike, well, why don't you just do that in the application? Well, yes, I can. I just think it's kind of neat to be able to do it a different way, to do it using streams, as it were, a stream type format. But so the brewer, very similar, right? You have the same the same setup, right? We're storing the ID, the name, city, and state. Okay, and this is all available on the GitHub repository I have for this. Okay, so simple POJOs. I'm not going to bore you with the rest of that. I'm going to have some helper methods here, helper functions or classes, I should say. We have a service class, and we are using the database and database type. That's part of NoSQL. And then we're using, well, it's JavaX for the moment. I think I know why this wouldn't work, the Jakarta, namespace, but that's something to fix in the future. Okay, so we're going to inject the database, right? We're going to call it beerdb, and the database.type you'll see is document. Now the corresponding ones, are graph and key value and column. And one thing I forgot to mention earlier is that the implementation for graph is actually Apache Tinkerpop. So I think that is being used for a graph type. All right, and one thing I also wanted to mention here is our microprofile config that we're using. So calling this DB1, you'll see a reference to that in a minute. And the database itself is beersdb, which corresponds to the name of the MongoDB database. And this is the default port in localhost for MongoDB. And the provider you would use, using the old method here, right, Diana, okay. But this is MongoDB document configuration. So this is how you would wire all that up right there. So, all right. So our service, going back to that, we have getter methods to get the beer repository or the brewer repository. You'll see that we use that to build some stuff here. Manager producer. You can see that here is, property name is DB1. You can obviously call it whatever you'd like. And this is more relevant if you're going to work with more than one database for whatever reason. You can have a couple of databases or MongoDB databases, for your application to do various things, for example. So this is kind of, to some degree, redundant, but it's there to show you how you can actually configure your database itself. Okay. And we have the corresponding, so we can, we have the close method here too for that, all right? All right, so let's see, where are we here? Let's close out some of these windows. And we're gonna have, there's two ways you can do this. There's the service or the repository. So let's look at both of those. So we have a beer repository and a beer service. Now I don't need both of these. But in the main application, I'm going to use both of them. So you see how they're used. They are slightly different. And in our beer repository, we're going to create the interface that extends from repository, which is in the Jakarta NoSQL mapping. And we're going to, it's a template that has beer and string. I should have said generic. It came from C++ before I learned Java way back when. So we're going to have the find by or find all methods that you basically just define here. In the background, these get implemented. So that's something you don't have to do. So we're going to find a beer by name. We're going to find a brewer ID by the brewer ID, and then you can delete by as well. Now, the last time I gave this presentation, somebody asked about updating. I'm like, did not do that. And I was hoping to have an example of that today. Unfortunately, I couldn't, but that's something you can do as well. And similarly, the brewer repository is the same thing. And in this case, we only have the find all and the find by name, as you can see. On the service side, you actually have to implement some stuff here. All right. So we're going to be using the select method here. Right, it's a static, and we're going to inject, configure, inject our database. It's a document template type. That's part of the specification. There's an insert method, and of type beer that you put this template.insert and then the name of the beer. And then here are the queries. We're going to find by name, all right? And so it's, document query equals select from beer. So this is relational database world, it's very simple. So, from beer where name equals the name being passed in here. All right. And then there's a build method. And then you use your template object to hit the select method that'll accept your query that you just built. And then similarly with find by brewer ID, right? It's the same thing. We're going to select, from the beer collection where brewer ID equals the brewer ID, and then build. And so we have the brewer repository. I think I showed you that. So I showed you that brewer service. That's the one. And pretty much the same thing. We're going to select from the brewer collection where name equals name. Okay. Questions? If you'd like to chime in and unmute yourself, that's perfectly fine. Okay. Doing pretty good on time. All right. Beer app. All right, so here's where everything comes together. So in Java SE, there's a built-in container. I am using the JavaX namespace, and like I said, I think that's in the Palm. I'm using an older version yeah, it should say something. So here's that. And again, you can look at that, and you can see I've been actually experimenting. I think this should be B3, and that's where I think is the issue. Of course, you don't violate that cardinal rule where you actually make changes the day of a presentation. So definitely being careful with that. All right, so you can create a container in Java SE, all right, by using this this statement right here. Okay. I had a logger here too. This is based off another example, but I decided just to do the system outs. So, all right, so we can create a service, an instance of service by using the container that you just created, and then using the select method and getting that. And our beer repository and brewer repository, right? We're going to use the service method to get the beer repository and the brewer repository. And if, let's see, service. And you can see them right there, right? That's how you wire that up together. And then you can create a service, which is kind of interesting because you're using a container to create the service, right? And then in the repository, you're using the service. So it's, it's kind of interesting, but these do work. Now you can use one or the other. And like I said, I'm doing both in this case, just to show how we use them. All right. And so the first thing I do is get the list of all beers and all brewers. All right. And we can obviously, because this is a list that it returns. And this way we can get the size of each. So, we do that, and then we'll, put that out onto the terminal window. And so this should be actually, it doesn't matter, it's a variable name. So first thing we're going to do is the brewer, and we use the builder that I described earlier in the Java bean, right? And we're going to set the ID to the number of brewers plus 1. And then the name of the brewer, we're going to call it Port Orleans, and this is located in New Orleans, Louisiana, and we'll build it. And then we'll take the brewer repository and use the save method, and then add the variable there. So this should be T, and then, yeah, okay. That looks better. All right, and then the other brewer, and this should be actually, there we go. One I just discovered over this past weekend called Screamin' Hill Brewery, which is in Cream Ridge, New Jersey, which is about an hour south of where I live. Okay, so one is, so we create those two brewers, and this one is using the brewer service, and instead of the save method, it's using the insert method. And that corresponds to, is the insert method right here. Okay, so we create that. There's other ways you can use the document template directly themselves. This is a work in progress. And then this is just a simple system outs, but we're going to find by name the brewer of Screamin' Hill Brewery. So we pass that in, right? And then we're going to get the brewer ID of this particular brewer. And the reason I'm going to do that is because I'm going to create two beer objects from that particular brewer. Okay. So we'll get the brewer ID here. And then now we're going to create two different beers, and we're going to use the repository and the service, for each of those. So here we use same thing. Here's the beer.builder. Okay. The number of beers plus one, obviously. The name of the beer, and then it's an ale, and then the brewer ID and the ABV, and then we build it, and then we use beer repository.save. And then similarly for the second one, obviously you're going to use the number of beers plus two, and the name is Oktoberfest, and it's a lager, and that has an ABV of 6. Okay, so we'll put that in, and then it's the brewer service.insert of the Oktoberfest. And then we can do some things here, some other just, little queries here and there. We can find a repository, find another beer by name called, Pum King, which is out by Southern Tier up in upstate New York. We'll find that. And then we can find the varieties of beer by the brewer ID. And the brewer ID is still going to be the Screamin' Hill. So in theory, everything should work such that it puts out to the screen the two new beers that we just put in there. So we're going to do a find brewer by ID, and then put that out onto the screen. And it's all going to be in JSON format because we created the two-string method that way. This is the way you delete. So it's a delete by ID, and you can pass in a number, for example. Didn't want to do that, but it's here. Update is, there is an update method, and at the moment I forget where that belongs, either the service or the repository, but it is possible to, let's say, oh, I messed up on the ABV, it's actually X versus Y, and you can update that way. So look for improvements and things like that in the GitHub repository. All right, let's see how this all work here. All right, so I have this going here. Let's make this just a little bit bigger. Okay. Let's, of course, just do all that first. And I know it'll build, but it's, I should do this first. It's I'm still using JDK8 in this particular one. It compiles with 11. I think that's what I had, but it's a 8 now. But let's just redo that with 8. And this is where this needs to be updated, obviously, to at least 11, right? And so, since I don't like to memorize these things, let's see it. Oh, okay. All right, so everything looks like it ran nicely. Let's take a look at what it did here. All right. All right, so there are 16 beers in the database and 23 brewers. And if you remember correctly, that's what was in there. Now let's see. So we're going to find a brewer by name, and you notice that we have the ID is 25. So obviously it created the two new ones. And if we look in our compass and we refresh that. Oh wait, this one here it is. Refresh that. So it's 18 now in the which we can see here. The Oktoberfest and the Pumpkin Pickin' Ale, and the ID is 25. And if you go to the brewer, just in case I'll refresh it anyway. Let's see. And then we go to the next screen, and you'll see it. Yeah, 24 is Port Orleans, and then Screaming Hill Brewery is number 25. So that'll work nicely. Okay. So we get the, find the beer by name. Oh, wait, let's see. Brewer ID is 25, adding the 2 new beers. Right, there we go. All right. And finding a beer by name. So we just chose Pumpkin. That's the first one that I actually put in this database. You know, the type is ale. The brewer ID is 1, and the ABV is 8.6. And then we're gonna, at the end, we put in, let's find the varieties of beer by brewer ID. And, you know, something to do too is I was kind of looking to make sure I didn't have Port Orleans in the database. That's something I can do is let's find it by city. Let's find a brewer by city, because, you know, I only had the 4 in there, and so I added the 5. So this is a good way of checking for that as well. So you can do that as well, just instead of find by brewer ID, you can find by city, for example. So that's easily implemented. That's pretty much it on there. Let's see. Any questions on the code at all? You can find that on my GitHub page. I'll show you where that is at the end. And let's wrap up the slides. There we go. Okay. Okay, so the current status of the specification itself, it's still in development. It is not part of the profile or the web profile or the platform profile of Jakarta EE yet. So hopefully that'll happen soon. So that means it will not be in Jakarta EE 10 as far as I know. I can double check that with Otavio. And then there was a plan to migrate to JDK 11 after the release of Jakarta EE 9.1, and that happened at the end of May. All right, some resources here. The specification itself can be found at that first URL. And then, you know, the others, you can go to that first part and then find the other specifications if you're interested in looking at those. This was a news item from one of the other editors that talked about Jakarta NoSQL and InfoQ back 2 years ago. There's a YouTube video, I think, featuring Otavio. And then Baildong has an early version, an application example on how to do that. So that's quite useful. And if you want to get involved, you know, the Otavio and the rest of the team welcome contributions, so please contribute. You can start by forking the NoSQL repository at that URL. And as far as acknowledgements, I want to acknowledge Otavio because he's been a big help to me. We've had a few Zoom sessions just to answer a lot of my questions and discuss what's what and the whole thing. So he's been a wonderful help to me in getting started with this specification. So can't thank him enough. Contact info, it's how you get a hold of me, Twitter account, my regular web page. I have a portfolio page, and the GitHub at the bottom there is that, and it's JNoSQL-beers, and you can find that there. And speaking of beer, there we go. Now it's kind of early for me to indulge, and I guess over in Europe and CEST time zone, it's only about 11 o'clock or so, not quite. But later on today, let's all celebrate the end of a successful first day of the conference here. So I do see something in the chat. I'm just going to stop sharing for the moment. Let's see. Okay. All right. Let's see. So, okay. How can I map NoSQL data to Java objects if its structure is not determined? Oh, that's interesting. So, yeah, that's in, somebody responded, Lumbach. Is it possible to make like searching? As I guess in wildcards, if that's if I read that correctly. Yeah, that's a good question. And at the moment, well, the short answer is I don't know, because of course with NoSQL databases, you can have your collections, or the documents within those collection, they can be different. You don't have to have a tightly structured schema like you would in the relational database world. And that's something I'm going to have to write down and research that as well. Thank you for that question. That is awesome. You know, I guess to some degree it is assumed that you know your data, but what happens if you're missing an attribute and you try to find it and it's not there? And so that I think is what the issue could be if you run into that problem. Trying to look for a piece of paper here. Thank you for that question. The other thing is I want to do an update at some point, and the wildcard, and that one I'd have to research as well. So wildcard, and correct me if I'm wrong. Is that what I understand? Is that being a wildcard? Let's see. Oh, okay. Thank you, Leon. Yeah, appreciate that. And then structure, or as it were. Yeah, yeah. So there's some things I need to definitely try to do to advance, you know, these particular presentations, and advance an application itself. I know this was getting started, but these are all great questions, and these actually help me to improve my knowledge of this and my participation in this as well. Let me stop sharing here. Yeah. Anything else? Any other questions here? I mean, I think I sure hope all of you had got something out of this. I hope I've inspired you to learn a little bit more, to hopefully get involved. And it's, Jakarta EE is really coming along now ever since it went open source 3 years ago, with the releases Jakarta EE 8, 9, 9.1, and 10 is coming up in at first quarter of next year. So look for that. Also, too, there's a new core profile in Jakarta EE, and there's it's a minimal amount of specifications to use Jakarta EE itself. I don't have the list of specs in front of me at the moment, but you can find out more if you go to the Jakarta EE website. Any other questions? If you want to put them in the chat, or if you want to just unmute yourself and just chime in, that would be awesome. Oh, the GitHub repo. Okay, I'm going to put that in the chat. Okay, I'm gonna have to do this to everyone here. Okay, so I think it's just easier if I just go to the website itself. Give me 1 second here. Okay. Okay, I put that in the chat right there directly, and I did make a couple of changes, so we can actually make the change right now. So okay, update that now. Any other questions? Oh wait, there's some other stuff in the chat I just realized here. Oh, okay. So somebody suggested here regarding map NoSQL data to Java objects if its structure is not determined. Maybe we can use an untyped option like map string object to types such as entity from the database. That's interesting. Yeah, I'll definitely take a look at that. Take a little screenshot of that. Okay, all right. Yes, so thank you for that, by the way. Yeah, so if there's nothing else, then I guess we'll call it a session, and thanks again, and look forward to all the other sessions the rest of this week.